Hi there. Welcome to Larbi Premium Educational Consult. This is also another session that we are having. And today also marks our first presentation on online studies that we are dealing with. So today we are going to deal with plane geometries as angles. So these are learning outcomes that we need to achieve at the end of the day. At the end of the day, we should be able to define what angles are, calculate the angles at the point, talking about the types of angles, properties of vertical lines, angle state, and use the theorem of triangle, identify various properties of special triangle, and state the properties of bilaterals, give a summary to whatever we have passed. So let's continue with the first learning outcome or learning objective. So, what are angles? What are angles? What are angles? So, we're talking about angles, right? So, what are angles? We are saying that angles are formed when two or more lines meet. So, if my hand or my thumb is a line, when they meet, there is an angle forming at this. In this area, there's an angle forming at this point. So that's what we mean by what? Angles. They are forming two or more lines meet. And this is an illustration here. If I have length A, B, and what? BC, there's an angle forming here, and also the angle forming. We'll get to know these angles, the big angle and small angle, when we start with the types of angles. So that is basically angles. So let's continue talking about angles at the point. We are saying that angles at the point, they are those angles in which their summation, their total will give you what? 360 degrees. When you sum up all angles at the point, you get you what? 360 degrees. So if I have this angle at the point B, like I said, if I sum up this and let's say here is x, and let's say here is what? Y. If I sum up x plus y, I'm getting what? 360. So that's basically the general knowledge you need to what get when it comes to angles at the point. Anytime you sum up angles at the point, you get what? 360 degrees. So let's take a question. All right, so we have two questions to be solved at angle at a point. So let's take them real quick. So first, we have to find the value of the lettered angles in the diagrams below. So these are first diagram, then these are second. We will solve the second question from this one answer. So the second question. So here, I have my solution here. So 3x, I'm just summing them up and I equate to what? 360. But we said angles at point when we add up the angles to get what? 360, right? So there is 3x plus what? 2x plus what? 20 plus 90 and equate to what? 360 what? Degrees, right? So are we adding like terms, right? So 3x plus 2x will give me what? 5x. 5x plus 20 plus 90 will give me what? It's what? 110. Good. 110 plus 110 degrees and equate to what? 360 degrees. So I can say that 5x then equal to 360 degrees. So for me to cancel off this 110 from the let's say my left hand side, I'll subtract 110 from this and subtract 110 from here. Or better still, when this 110 join 360 becomes what? Negative. Okay. So I can say when it joins it becomes negative degrees. So I can say that 5x then equal to what? 250 degrees. Or when I take 110 from 360, I'm guessing what? 250. So I divide both sides by 5. Both sides by 5. Therefore, my x equal to what? 50 degrees. So that's the value of my x. So I'll just give you 10 seconds. Solve diagram 2 for us. And let's see. 10 seconds. For my time, the time is up, okay? For my time, it runs pretty fast. So the time is up. So let's see whether you had it right. Okay, so here to the same solution. So the same idea still works. 2x plus 90 plus 178 and equate to what? 360. So it becomes 2x plus 178 degrees plus 90, then I equate to what? 360 degrees. So I can say that like them here are just the numbers 170, 90, and then 360, right? I can say that 2x is then equal to 360 degrees minus, when I add 178 plus 90, I'll get them what? That's 268, right? 268, 268, 268. So I'll be getting 268. When I subtract from 2, I'll be getting 92. I can say that 2x go to what? 90. Divide both sides by 2. Divide both sides by 2. Therefore, my x is equal to what? 46 degrees. 46 degrees. 46 degrees. So that would be, I hope you had this right. So if you had this, clap for yourself and buy one token for yourself. Okay, good. So that is the angles at a point. That's how we deal with angles at a point. So we are moving on to another section on types of angles, and how they applied when it comes to application. All right. So let's see. All right. So we are moving on to types of angles. We are moving on to types of angles that we have. So our first angle that we'll be dealing with is an acute angles. 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 So what are acute angles? We are saying that acute angles are those angles that are greater than what? 9, that are greater than 0 degrees but less than what? 90 degrees. There are those angles that are greater than 0 degrees but less than what? 90 degrees. So if I have this illustration, let's say I have this line, I have one line B drawn. So let's say here is A, here is B, and let's say here is what? C. Yes. Okay, let me have this one to be D here. So the angle formed at this point or this area is what we mean by what? An acute angle. Realize that this is another angle. We're talking about that one later on. This is an acute angle, but it's less than what? 90 degrees. But greater than what? 0 degrees. So mathematically, you can have an expression like 0 degrees, which is less than x, and less than what? 90 degrees. That's if I'm reading from this side. If I'm to read from the x side, x is greater than 0 degrees, but less than what? 90 degrees. So that is an acute angle that we need to know. I hope you are okay with that. If you have any question, you can comment below, then I can give you feedback, chance. Okay. All right. Then our next angle that we'll be dealing with is what we call an obtuse angles, an obtuse angles, an obtuse angles, obtuse angles, an obtuse angles, an obtuse. So our next angle that we'll be dealing with is an obtuse angles. We are saying that obtuse angles are also those angles that are greater than what? 90 degrees but less than what? 180 degrees. Obtuse angles are those that are greater than what? 90 degrees but less than what? 180 degrees. So in mathematical expression form, I have this illustration. So I have this line, let's say this time around, I have this line, vertical form. Then I have this line, let's say A, B, C. The obtuse angle we are talking about here is this. Why? Because later on we dealing with what we call angles on a straight line. Angles on a straight line tells us that if I have angles on a straight line, they sum up towards 180. But I realize that this angle is greater than this, and in so doing, it is greater than 90 degrees but less than what? 180 what? Degrees. It's greater than 90 degrees but less than. So That's an obtuse what? Angles, obtuse angles, obtuse angles. Right. So it's greater than what? 90 degrees, but less than what? 180. So I can say that, mathematical expression, I can say that 90 degrees less than x, less than what? 360 degrees. So I can say x greater than 90, but less than, but less than what? 180 degrees. That's an obtuse what? Angles. All right, so our next angle we're dealing with is what we call complementary angles. Complementary angles. We are saying that complementary angles are those angles. When you sum them up, you're going to get 190. So be with me. Complementary angles are two angles. Now when you sum them, you're going to get 90 degrees. So if I have this illustration, I have one line being from this side and another line from here. Let's say here is what? O. Then here is, let's say, A, B, C, and D. That's my illustration. If I have angle A here and angle B here, we are saying that if I add up A plus B, I'll be getting what? 90 degrees. That's what we call complementary what? Angles. Two angles. That the summation will give you what? 90 degrees. All right. If you have any question, comment below, then I can give you a response to that as well. All right. Then the next angle that we'll be dealing with what we call an obtuse, a right angle. A right angle. A right angle. We are saying that the right angle too is also another type of angle that have an interior angle of what? 90 degrees. Have an interior angle of 90 degrees. So see, if I have this vertical line being joined by a horizontal line, we have a nice horizontal line then forming 90 here. This is what we mean by what we call a right what? Angle. We have an interior angle of what? 90 degrees. So the difference between a right angle and that of what? A complementary angle is that the complementary angle, there are two angles that will give you what? 90 degrees. But right angle, just one interior angle giving you what? 90 degrees. So you need to know that when you encounter any problems on that, you can give us a clue to that. All right. So the next section that we are dealing with is what we call a supplementary angle. Supplementary angle or angles. We are saying that supplementary angles also have another name called angles on a straight line. Angles on a straight line. So there are those angles that their summation will give you what? 180 degrees. These are angles in which when you sum them are going to get what? 180 degrees or 180 degrees. So if I should have a slanted line like this, and I have one drawn from this point and the other point. If I have, let's say here is A, B, and here is C. We are saying that these angles are complementary. Why? Because when we sum them, we'll be getting what? 180 degrees. So I can say that A plus B plus C is equal to what? 180 degrees. I hope that is clear. All right. So if you have any questions, you know what to do as well. Then let's see. So far so good. We have been able to complete at this level. You should get these kind of angles that you need to be dealing with, right? So these are angles that we have. We have discussed an acute angle, obtuse angle, complementary angles, right angles, supplementary angles, which are also called angles on the straight line. Angles on the straight line. Angles on a straight line. Angles on a straight line. So these are a supplementary ones. Angles on a straight line. So let's move on. We'll be taking a full question on these angles. I want us to add the properties of parallel lines in angles. After I will take a full question on that as well. Right. So let's take Let's continue with properties of parallel lines in angles. 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 So let's continue with properties of parallel lines in angles. After that, we take a question together with the types of angle we have placed down right now. All right. So if I have these two lines, let's say line AB, then line C and D, right? Now, we are saying that these lines are parallel lines. What should I draw lines? So let's continue. So if I have these parallel lines, what should as parallel lines? There is this arrow that shows that they are moving in the same direction. They won't meet. So that is probably a parallel line. They will also have the same gradient, irrespective of their magnitude. The gradients will still hold since they are moving in the same direction. Then there is this line that's cut, a slanted way and an oblique sectional form. We call it a transversal line. A transversal line, oblique line, or slanting line, right? So it cut across. We said angles are forming two or more lines, right? So here an angle is forming because there is a line meeting, right? So we have angles forming in various sectors that we are talking about, right? So now we are saying that from this diagram, you can clearly see these shapes. I can see this shape, a slanted F, right? From here, let me use a red marker to which slanted F I'm talking about. Here a slanted F where these arrows are indicate, right? Then also you also see a Z shape from A to this, then that, and that. A to this point, then to this point, and to D, right? We call it Z shape with an arrows showing that they're moving in the same direction but they won't meet. Then also we also have this shape, this, that, and that. Also moving in a direction where they won't meet. So you are saying that with reference from the diagram and these angles, you see that there is this angle within this F I'm talking about. For example, here is A, then here is C. They also have an angle Y and C as well. They also have, yes, they also have A and what? Angle E. You can see that with this angle, you can see that Y and C are on the same position, though they are on different power lines or different magnitudes, on the same position. We set angle, we set relation, we call it corresponding angles, because they are on the same position. I hope you get what I'm trying to say. Because they are on the same position, we call them, they correspond. They relate to one another. So that's why we call them corresponding. So if here is 20, here is also 20, you also 20. Hope that's clear. Good. Then also, you also have A and C. You see A and C are within this line that we produce from this diagram, right? So we are saying that there is this property that is saying that if I should add A plus C, they will fetch me 180 degrees, or their result to 180 degrees. And that property is what we call, that property in parallel, we call it co-interior angles. Angles, when you sum up two interior angles within a solid shape, you'll be getting 180 degrees. So that is called interior angles, right? Then also, you can see that from the Z shape that we produce, this Z shape that we produce, right? We have Z and C here. So I can say here is Z. Then here is C. So what I'm talking about, Z and C, right? With this angle, we call them alternate angles. They alternate with one. You can substitute one for the other because these angles will the same. We call them alternate angles. Alternate angles. So anytime you see Z shape with an arrows moving in the same direction where they won't meet, we call them such angles within that Z shape, we call them alternate angles. And likewise this as well, where you replace the A and that of what? B. We also call them what? Alternate angles. Why? Because they are moving in a direction where they will meet. There is this arrow showing that they won't what meet. So anytime you see a question where we have this arrow show, then you can apply your alt angles or alternate what angles. I hope that is clear. So far I'm talking about corresponding angles, co-interior angles, and alternate what angle. So you clearly see that X and B are corresponding angles, right? Y and C are corresponding angles. Z and D are corresponding angles. A and E are corresponding angles. Likewise, co-interior angles, A plus C will fetch me 180, right? Co-interior. Z plus D also fetch me 180 for co-interior angles. Then also talk about alternate angles. Z and C will fetch me what? Alternate angle. They are the same, so it's alternate angle. Then A and B are also the same angle because of what alternate what property that we are choosing. All right. Then also there's also one last property that we need to talk about. We call them vertical opposite angles. Vertical opposite angles. If I should take X and B, you see they are vertical opposite. They are facing each other. They are facing each other. So with that, we can say that X and A are what equal because they are vertically opposite. They are facing what each other. So we call it vertically opposite angles. Likewise, Y and Z, C and D, B and what T, we call them what vertically opposite angles. So that is it for vertically opposite angles and angles we are talking about so far. So we are going to take two questions, let's say three, where we summarize what we have done so far from the types of angles to that of properties of flat lines. Then we will continue from there. All right. So stay tuned with us so that as we get with the question and dealing with it real quick. So that's our question on properties of flat lines, other angles that we have just done. So let's look at this because we are asked to find the value of the reflex angle y. This is reflex angle y. So reflex angles that are greater than what? 180 degrees, but less than 360. I think we didn't talk about this, right? Okay, so now you know. Reflex angles are those angles that are greater than what? 180 degrees, but less than 360 degrees. That's reflex angle, right? So here, for me to solve for y, I need to get the whole of this angle. The whole of this angle. I need to get the whole of this angle now, right? So you can see that now I have ADF moving in a direction with this line showing that they are parallel lines, right? But now, so if I should create also another parallel lines, whether on top or above what they made, you also have the same parallel relation with what AC and what DF, right? So that I can easily get this angle, then I can solve for. So I can say that. So let's continue. Right. So as I was saying, for me to solve for this, I need also have a power relation of AC and what here by creating what the power line pass through this. Right. Say I'm using this short as because they are not part of what the lines in the question, right? So once I do that, I'll be having a Z shape here. So if here is 40, here is 40 because of what? Alternate what? Angles, alt angles. Remember the Z shape with an arrow. I just taught you right now. Right, good. Then also, I can also see a Z shape here. So, but I don't know this, but I can easily find this. That's angle to show you like supplementary angles, right? So if I subtract this from 180, I'll be getting it 40 degrees. So once you write it, 140 plus, let's say this angle is equal to what? 180. Then subtract from 180, and you'll be getting what? 40 as your answer. And this 40 is alternate to this angle, right? Because of the Z shape and the power line that they are moving. So therefore, I can say that therefore, my solution, therefore I can say that y is equal to 40 plus 40 plus y, sorry, therefore I can say that y is equal to 360 degrees minus 40 plus what? 40. I can say this, or should I can say that, or I can say that y plus 40 plus 40 is equal to what? 360 degrees. 360 degrees, I can say something like this, or something like this. So therefore, I can say that y is equal to what? When I take this, I'm getting what? 280 degrees as my answer. So there's a problem on points of one lines and other angles that we just deal with. Remember, this is an acute angle, right? This is what we call obtuse angle. This is what we call alternate angles. These are reflex angles. Then we don't have other converts. They are all still apply. So this is the reason why you need to get these properties so that you can easily solve questions like this, right? So this is where we bring an end to the section of this section. So if this video was helpful to you, please do me a favor by giving us a thumbs up, by liking this video, subscribe to our channel, and share this video to as many students as possible who may be interested in this kind of videos to help them study academically and to pass any exams or any fairness that they want to engage in future. So thank you for watching me once again. My name is Larbi Benjamin, Director of Larbi Communication. You can also like our Facebook page at Premium Educational Consults. Then to send you there, then you follow us as well. So thank you once again for watching this video. So please do me a favor by giving us a thumbs up, share, and most importantly, subscribe to this channel so that we can do more videos for you to enjoy instead. So be with us and wait for any update that will be released. Right. So we'll be discussing more in the next video that we engage on. So thank you once again. Bye bye.